Well, as promised, I went ahead and did an additional walkthrough video, this time using the fractions 1/2 and 3/4. I did wait a little bit to post this to give you a chance to see if you could self-correct with the earlier version. What I find is that every time you practice, you get a little better at something. And so if nothing else, you'll have another opportunity to make sure your work is correct. You'll also have a chance to see a walkthrough again. So at this point, you will have read the information. You will have tried your best. You will have checked with a walkthrough with different numbers, and then you'd see the walkthrough with the actual numbers that was part of your assignment. Be sure to make any corrections necessary before you post, because you want to make sure that you have your best work put forward on Blackboard. The other thing that I would encourage you to do as you go forward with this is each time you go to teach these ideas, just spend a moment or two to practice them. What happens is they are very obvious as you're seeing. And because of the fact that the sketch is what you're acting upon, you're really doing two things at once. You're generating the record of action while you're performing the action. That can work for you, but it can also work against you. The way it works for you is what you do is very, very obvious. The way it works against you is if you make a mistake, it is also very, very obvious. And so I would encourage you to spend a little time practicing these until the models are natural for you.
In this video, we are going to use the fraction template to give you a chance to walk through and self-correct your assignment. I realized a little too late that the original walkthrough used different fractions than what your assignment was, and so we'll go ahead and very quickly go through the assignment that you should have completed. And so the first thing we have to do is we have to be able to represent each of these two fractions. And the key here is to remember how to read them. We read this as share with 2 and take one of the two shares. We would read this one as share with 4 and take 3 of the 4 shares. And to help build a comparative form later, what we do is we'll share one of them horizontally and one of them vertically. And as you saw in our discussion, that really buys us quite a bit over the pie or the pizza model compared to some of the others. So first step is to represent, and so we have now represented both. And the key here that I hope you're seeing is that this way of reading this instruction makes us in a position where we know what to do. It's not just a symbol to memorize, it's an instruction to follow, an action to perform, if you will. So we are going to perform this action upon this sketch object. Now, at this point, we are to the position to where we should build a comparative form. And the way we do the comparative form is we cut each cake so that it looks like the other one. So since this cake had already been cut horizontally, we'll cut it into the number of vertical pieces we have over here. Just as now we're going to cut this one horizontally so that it matches. Now, since we know that this is a unit square, that means that each of these pieces are the same size and the same shape. They're congruent with one another. And so we'll count them up. We have 1, 2, 3, 4, 4 pieces here. We have 1, 2, 3, 4, 5, 6 pieces here. And because we're used to seeing the area model, one of the things that we should be able to point out is that there's 1 in this direction, there is 4 in this direction, and I've been trying to show how this helps us in terms of making sense out of the old cross-multiply model. So when we look at what number goes up here, it's 4, and it's 4 times 1. when we look at what number goes up here, it's 6, and we get that from 2 times 3. I'll go ahead just for completeness sake and show there's my 2 and there's my 3. Now, we don't get that just automatically. It does come with the fraction cake. It doesn't come with other models, however. So if you use Cuisenaire rods, if you use pizzas, if you use circles, if you use other approaches here, you will probably not be able to get this to be as easy to follow. And so that's why the old cross-multiply method was frowned on for so long, is because people didn't understand it. Now, the nice thing about building the comparative form is it gives us everything that we need in terms of doing our first 3 operations. And I guess I should say our first 2 operations, because I'm going to count addition and subtraction as one operation. So when we look at what we're doing here, I want to stress something about the comparative form. I'm just going to draw down here what that cake looks like when we cut it in both directions. And we would count up just how big is each of these pieces. And so in addressing that, we would recognize that we have an area of 2 in one direction by 4 in the other. So that means that each of these pieces share that entire cake with 8. So if I have one of these pieces, that would be share with 8 and take 1. If I have 2 of those pieces, it would be share with 8 and take 2, and so on. This gives us a chance to kind of talk a little bit about equivalent fractions, and so I'm going to take the opportunity to do that. When I look at what I've done here, how would I record that? Well, I would record it share with 2, take 1. What happens if I cut it again? How would I record that? Well, the first thing to recognize is I still have the same amount of cake, so I'm going to have an equivalent relationship, only now I have 1, 2, 3, I have 4 pieces. Of the 4, I have 2 that I've actually taken. So you see, we're getting into equivalence, aren't we? If I cut it again, now I have 1, 2, 3, 4, 5. I have 6 pieces in all. 1, 2, 3. I have 3 of the 6. And because we're not changing the actual representation here, we're just cutting it into more and more pieces, each of these fractions are equivalent to one another. And so, I'm sure some of you were wondering about, well, when are we going to talk about reducing and equivalent forms? This would be a good time to introduce that. So if I see something that is shared with 8 and take 4, I could arrange that in such a way that I have a simpler instruction that gives me the same amount of cake, don't I? Now, if I wanted to finish our operations, the first operation is that of comparison, and I see that I have 6 pieces over here, I see that I have 4 pieces over here, and so all I have to do is build a record of that action, because I can tell that that's larger. And I can write this in one of 2 ways. I can either write it like this, or I can use the comparative form, which is share with 8 and take 4. And where do I get the share with 8? Well, the share with 8 comes from here, doesn't it? That's the total number of pieces that we have in the whole thing. And over here, I would have share with 8. I guess I better point to the over here, right? I would have share with 8 and take 6. And this is actually quite a bit easier to see, isn't it? I have 4 pieces, I have 6 pieces, and we know from the comparative form that they represent the same amount of the smaller pieces, so I'd rather have 6 of something than 4 of something. assuming, I guess, that it's something that I actually like. Now, if I wanted to do my addition subtraction at this point, let's do subtraction first. That's generally the way we approach this, and so we'll go ahead and we'll approach it that way at this point as well. Well, what is it to do that? Well, let's write it in do it dang it terms. We represent, share with 2, take 1. We represent, share with 4, take 3. We do it dang it. What do? We do pairwise removal. And so as I look at that, I'm going to use a highlighter to just show what happens as I take these out. I'm going to take 1 away from here, and I'll take 1 away from here. I will take 1 from here and 1 from here. Remember, pairwise removal. I'll take 1 from here and 1 from here. And finally, I'll take 1 from here and 1 from here. And I'm done, aren't I? I can't go any further. Well, what do I have left? Well, I have this small piece. I have 2 of these small pieces. So I have 2 of these small pieces. And how big is each one? It's what happens when I share with 8. So I share with 8 and I take 2. Now, if I'm very clever, one of the things that I can see is I can say, okay, these are 2 of those pieces. I could rearrange those, couldn't I? I could put 1 of them here, and I could put 1 of them here, and that gives me a different way of describing it. So I could describe it as share with 8 and take 2, or I could describe it as share with 4 and take 1. Again, you'll notice that we're getting the full benefit of this equivalent form, aren't we? We're able to use that now to show equivalent names, and that's helping us in terms of reducing. When I initially teach, I don't spend a long time dealing with such things as common denominators or greatest common multiples or least common multiples, at least initially. I'm focusing more conceptually. As we observe things, we start seeing where some of these things naturally fall into place, like equivalence and lowest way of recording something and simplest form, and we can generate that vocabulary once the object is clear and once the actions are clear. So I guess we can smush them together now. Let's see what happens when we smush them together. That's our addition, isn't it? So I have 1/2, which I've represented. I have 3/4, which I've represented. We're going to do it, dang it. And we're going to do the operation of smushing them together. I suppose I should probably note down here that if we use the equivalent form, we would say that share with 8 and take 4, and share with 8 and take 6. And when we subtract those, we'll have to kind of subtract going this way, but it's share with 8 and take 2. So, you know, we kind of have them in the wrong order here to make that obvious. I guess we did the same thing here too, didn't we? Sorry about that. Just kind of reverse those in terms of the order that we have them. Now, when we smush these pieces together, we've got 4 pieces here. We've got 6 pieces over here. So let's see what happens. I'm going to take this piece and I'm going to move it over to here. So we're just going to pretend now that I've moved that piece over to here. I'm going to take this piece and I'm going to move it over to here. And look what we've got. We've filled that whole thing up. It's a completely full cake. So we have 1 full cake. And then we have 2 out of the 8 pieces that are left. And because we know now that that's also the same as share with 4 and take 1, we could write that as 1 and share with 4 and take 1. So far, so good. Now, the next 2 operations, multiplication, division, will require a slightly different approach towards taking the record of action, particularly for multiplication. And so what I always do is I record both of them on the same form. So what we've got is we have something that is 1/2 in one direction by 3/4 in the other direction. So if I look at it, my 1/2 is from here to here, and my 3/4 is from here to here. So I'll better shade that in, shouldn't I? There I go. Now, because we understand the area model for multiplication at this point, we don't have to concern ourselves with all of those pieces. In fact, the only pieces that are in that area model really are those that are 1/2 in one direction by 3/4 in the other direction. So in looking at that, that makes it very easy for us to see what we have. We have our 1/2, we have our 3/4, we do it, dang it. We do the operation of creating an area model, and when we are done, we have the whole cake divided up into 8 parts, and we have 3 of those 8. Really is that easy, isn't it? Kind of a surprise sometimes for people when they realize just how easy it actually is. For division, we do need to go back to our full template at this point, and we have to create the equivalent forms. And the nice thing about it is because we've done this a few times now, we're getting a little bit faster at it. And so I know that I have 4 pieces over here, and over here I have my 6 pieces. And what makes division difficult, I believe I mentioned this, is that we have to be able to flexibly redefine what counts as the unit. And so when we're asking the question, what is 1/2 divided by 3/4, the real question we're asking is how many times will these 3/4 fit into the 1/2? So how many times will 6 fit into 4? And if we just common sense our way through it, we realize that all 6 of those won't fit. In fact, of the 6, only 4 will fit. And we can see that. We can fit 1, 2, 3, 4. Well, only 4 of the 6 will fit. And we may or may not recognize that that could be renamed. I'm not going to worry about it overly much at this point, though. When we ask ourselves, what is 3/4 divided by 1/2, we're saying how many times will this 4 fit into this 6? And this time we have a slightly different situation. In fact, that 4, there's my 4, will fit over here once for sure. 1, 2, 3, 4. And in fact, 2 of the 4 pieces will fit again. So that tells me that it will fit 1 full time, which is what we've done so far, and we can keep track of that. 1, 2, 3, 4. And then of the 4, 2 of the 4 would fit again. And again, we may recognize that this has another name that we could apply to it if we'd like. Now, for those of you who are old school and like to check your work, we could do the procedure at this point, and that is to multiply by the reciprocal. There's my 4/6. And there is my 6/4. And with a little bit of head standing, we could show how 6/4 would be the same as 1 and 2/4. I hope this gives you another opportunity for you to self-correct your work. I'm sorry that the initial walkthrough used 2 different fractions. If nothing else, though, you have at least another opportunity to make sure you understand what's going on. I do encourage, as always, that you practice these until they become second nature for you. Once you've done that, you'll be much more able to teach with them effectively when you get into your own classroom.
I hope that you have realized the importance of the area model for multiplication. If nothing else, you will see how the fraction cake model relies on that area model to explain the cross-multiply approach that many people still take. Cross-multiply has gotten a bad rep because people don't understand it. Your students can understand, though, if you use the appropriate fraction model. So that's something that I think you'll find should work well for you. Please feel free to practice this until you are good at it. I am not going to be asking how many of you really love doing fractions, because from past experience, not everyone enjoys it that much. However, as future teachers, you have to be able to teach them whether you enjoy them or not. And so, here is a model that I am guessing some of you might have had a few ahas and eurekas over, but in any event, be sure you feel comfortable with this when you go to teach. It's part of the curriculum. We need to be good at it. We need to be able to be sure the models that we put forward allow our students to represent, to compare, to add, subtract, to multiply, divide.